Now I'll cover the final two example problems for section 2.3. Again, if I were to actually substitute the number that I'm evaluating the limit at, 9, I'd get the square root of 9, which is 3. 3 minus 3 is 0. 9 minus 9 is 0, so it's a 0 over 0. All of the example problems that I've been doing are 0 over zeros that we need to take the limit. What I look at when I look at this problem, there are a couple ways to do this problem, but I recognize that the square root of x is the square root of this term, and then 3 is the square root of that term. So I'm going to use the difference of square patterns in a weird way to actually rearrange this limit. So what I'm going to do is I'm going to rewrite this as the limit as x approaches 9. I'm going to leave the numerator alone. And then in the denominator, I'm going to rewrite that as the difference of square patterns. I'm going to take the square root of the first term plus the square root of the last term times the square root of the first term minus the square root of the last term. And you notice that I have a common factor in the numerator and the denominator now. So rewrite my limit as x approaches 9. Take the 1 out of the numerator, I get a 1. Take the 1 out of the denominator, I'm left with the square root of x plus 3. I can now evaluate the limit because I'm not going to get a 0 in the denominator. Put a 9 in for x. The square root of 9 is 3. 3 plus 3 is 6. So my final answer is 1/6. So this is one of those patterns that, hey, normally you see like x squared minus 9, and that's the one you want to factor it. Just realize that if you see something that's a square root of something else, you can leverage that tool to rearrange your problem. For this one, we're going to do the typical method of rationalizing to get rid of this square root. To rationalize to get rid of a square root, you can multiply the numerator and the denominator by the conjugate of the numerator, which is another thing that I could have done for this problem, as I could have rationalized it using the same method I'm going to do here. I showed you this method on this one because it won't work on this one. I wanted to show you two different things. So here, I need to rewrite my limit. So I have the limit as h approaches 0 of 16 plus h minus 4 over h. Multiply the numerator and the denominator by the conjugate. 16 plus h plus 4 over the square root of 16 plus h plus 4. Now, this right here, if you look at it, I don't need the parentheses as long as I keep the time sign there. This is a difference of square pattern. And it's a memorized pattern that your answer is going to be the first term squared minus the last term squared. So I get the limit as h approaches 0 of the first term squared, which is 16 plus h, minus the last term squared, which is 16. And I am going to leave the denominator as a multiplication problem. And you'll see why when I get done with this step. And my recommendation is you never multiply this out when you have this type of problem, because you're always going to be able to do what I'm going to do in the next couple of steps. So I want to simplify what I can in the numerator. 16 minus 16 is 0. So I'm going to rewrite my limit as the limit as h approaches 0 of h, which is that h there, over h times the square root of 16 plus h plus 4. And now you'll see why I did not multiply out the denominator, is because I have a common h in both the numerator and the denominator, which will cancel. So one last time I'm going to write the limit. It's the limit as h approaches 0 of 1 over the square root of 16 plus h plus 4. And now I can actually let h go to 0 because I will not get a 0 in the denominator and I won't have a negative number underneath the radical. So if I put a 0 in for h, I get the square root of 16, which is 4. 4 plus 4 is 8. And I get 1 over 8. So, again, the key thing on this type of problem, which you will see every time that you have a square root function that we are trying to take derivative of, or we're trying to find the difference quotient of, or find the instantaneous velocity, those types of problems, anytime you have a square root minus a number, that you can't do this trick here. If it's just over the h, you multiply the numerator and denominator by the conjugate. And in the denominator, do not multiply it out, because you are going to be able to cancel out the h from the numerator, which is going to allow you to simplify the function at the end. So a couple of key points. Do not multiply out, otherwise you'll have that h floating around and you may miss it for canceling out. And multiply by the conjugate, and that's called rationalizing the numerator. Before, you've always rationalized the denominator, but because we are actually going to be evaluating, it's no problem leaving that square root there before we evaluate.